Hello, my name is Kalman Reti, and this is a reconstruction of my solving the Advent of Code 2022 Day 3 problem this morning. I solve it in the mornings on an Android tablet in bed, but it's hard to capture and make a video of such a solution. So I'm going to recreate it using the same version of Emacs, but on my personal Windows 10 laptop. So the first thing we need to do is we need to go to the Advent of Code problem. I have already downloaded my input, which is the second tab here. And I've also already started the file, which is going to hold the solution. On my Android tablet, I have a Emacs Lisp function that you specify the year and the day number, and it basically fills in more stuff than this, but this is only. So this variable is going to hold the input that I'm given. That's my personal input. This is going to hold any part 1 sample. Sometimes there's part 2 samples, so the one on my tablet actually generates a def for a part 2 sample as well. And of course I can copy and paste and add more if some in years past there have been more than a few examples. And the this require CL is because I heavily use the loop macro, the common Lisp loop macro. In fact, many of the functions the bodies are essentially just a loop macro invocation. And then these are the skeleton versions of the function. The part 1 function that takes the input string, which is this guy. This is an example of how you invoke that using the sample data, and this is an example of how you invoke it using the real data, and then the empty one for part 2. So far in 2022, the second function works on the same sample, so this uses the part 1 sample. Anyway, so back to the actual problem. So the input data is lines that look like these, which I'm going to copy because this is the sample data. I'm going to paste it into here. So usually, I know from having done this before that there were no backslashes or double quotes in the actual data. Usually, if there's the possibility that there are, I copied into another buffer, and then I basically replaced all backslashes with double backslashes, and all double quotes with backslash double quote. And then that contents of that buffer can be the thing that you put between the two double quotes to hold that original input. Similarly, I have already gotten the real input in this tab, so I can go and put that here. It's long, and we're not going to really pay much attention to it, but you can see that it superficially looks about the same. I'm typing one-handed, so I make some circumlocutions that I wouldn't if I were not typing one-handed. So back to the problem. I don't need this one anymore. So each one of these lines is representing the types of things that are in a rucksack that an elf carries. And the rucksack has 2 equal-sized compartments, so the length of this line is always a multiple of 2. And the types of things are supposed to be segregated across the compartments, but due to a snafu, for each one of these elf's rucksacks, there is a single type that is in both the compartment 1 and compartment 2. Now the types are made up of the lowercase letters and the uppercase letters, so A through Z, and capital A through capital Z, which is 52 different types. And what you are asked to do in this problem is to find the one type in each rucksack that is, misplaced so that it's in both halves, and get the priority for that type. So they assign the priority by having the lowercase letters be priorities 1 through 26, and the uppercase letters being 27 through 52. And then you need to add up those priorities, and that's the puzzle answer. And so they give you the actual, answer for the sample. So they tell you that the thing that's in common is the P, the capital L, the capital P, and that the priorities then add up to 157. So we have to basically duplicate code that gives us that answer. And then presumably we run that code on the real input and get the real answer. So now, as I said, almost always I start with loop. Now, loop allows you to have variable bindings that persist for the whole loop, and I'm going to do them. So the types that we have are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, X, Y, Z. So I've just created the lowercase and uppercase. I'm going to check to make sure I didn't leave anything out. The length of that string is 52, so I'm good. So we're going to use that types variable to generate the priority for, except I didn't want the paren there. So we're going to use that types variable to generate the priority. So we need to look at each rucksack. So this is going to be for rucksack. Now each line is a rucksack, so we're going to say split string input string on new line. So that gets us the line that contains the and we need to know the length of the rucksack. For L equals length rucksack, and we need to find out what the common priority is, and we're going to do that by loop. Oops! So my hand hit the trackpad, which acted like a mouse click. Wish I could turn that off, but. So for loop for I below, actually compartment L equals 4L2. So half the length of the rucksack is each compartment size, and then for I below compartment L, or J from compartment L. So this allows us to have a loop that's going to only go through, half the things, but it's going to have two indices, an I for the first compartment and a J for the second compartment. And we want the priorities of the things. So for L, priority, position, aref, rucksack, I. So the I in types for R, priority, same thing, but J. So that's going to tell us, in the relative position on each half of the rucksack, what type we've got in there and what its priority is. And so what we have to do is we have to record, the ones we've seen, so we can take stock. So for scene equals make vector, and down, one of the cool things about Emacs is down here it tells me that it wants the length. It's going to be 52 because that's the length of the types, and then it's going to be the initialization value. Nil is perfectly fine. I'm going to be collecting lists. So what we want to do is push new L onto scene L priority and push new R. So I have to spell push right. AF scene R priority. I know it does that. I don't like that indentation. So we are told that there's exactly one common one. So now that we've pushed that we've seen L and R, if either one of those has the other one in it, then we know that we've found the matching one. So when member L iref scene R priority. So that means we already pushed a return R priority R iref scene L priority and L priority. And that's it. Now, I could make it sort of checking and in fact I'll usually do something like that. So now what we have to do is we have to add up the priorities. Now our priority is 0 based, and they wanted 1 through 52, so we have to sum 1 plus common. And we're done. I don't know where the ending of that one went. So let's, so I'm going to do metax eval buffer. That evals the defvars. Oops. So with types equals that's better. And let's try it on the sample. Remember, it told us what we should get. 157. Actually, what I usually do is this. Which puts it into the buffer. And that is in fact the right answer. So we can just, what I'm doing is minus control meta at, which marks an entire expression. Meta W to copy it to the kill ring. Control U meta colon, that evaluates the expression the same as meta colon, but it puts the value into the buffer. Yank back in that expression. And so that's the answer. So going back to the problem, we'll see that that's what I typed, and I got it right. So part 2 is interesting. It's pointing out that each that the lines are actually grouped in three, where each group of three is an ELF sort of triad, and they're identified as all belonging to the same triad by having a type in common. And there's only one such type. So what we're asked in part 2 is to find the types in common for each of the three L's and sum up their priorities. And that is one of the the few times in Advent of Code where you can actually solve the second part in smaller amount of code than solving the first part. Anyway, they give us the answer for the sample, which is 70. And so let's go, and I'm going to start by copying the same thing I had into the empty second part one. But for one thing, we don't need this, because we're going to look at each. So we also need an index to tell us which rucksack we're looking at. So I'm just going to say index I from 0. So every time we go through the loop, I gets incremented. Still same rucksacks, the same length. This time, though, we have to remember that we saw this vector across 3 different rucksacks. So for one thing, it can't be here. The for clause makes it creates it each time through the loop. We have to have it be, persistent across multiple ones. And I'm going to, instead of filling it with 0, I'm going to fill it with 0. And my plan is to use collect the number, which is the bits, for whether we've seen it in the first ELF's rucksack, the second ELF's rucksack, and the third ELF's rucksack. So something that's in all 3 would have the number 7, because the low order 3 bits would all be set. So so I can get rid of most of this. Control U, Control Meta K, Control U, Control Meta K. One of the cool things about the loop macro is that loops, clauses come in usually in sets of 2 or 4, and so you can kill them, perfectly easily. We also don't need I and J, but we can't use I because we're using I in the other one. So we'll use II below L, only J, and instead of an L priority and an R priority, we just have a priority. And instead of pushing onto the scene thing, what we're going to do is we're going to use the setf macro. Setf is a great thing. And we're going to OR in to what's already there, #1 mod I3. That would have been an interesting bug to chase down. I don't need the other thing. And we're doing this for everything, so there's no need for a finally clause. So as I said, this one is closed. Now there's this has to happen for every single line. We have to keep track. But then there has to be something that happens only when we're on the last one. So when equal to mod I3. So that means we're 0, 1, 2, 0, 1, 2, 0, 1, 2. So this means we are on the third of a triad. So we're going to loop for S across scene, and keep an index for II from when equal S7, return II. And finally, we should never get here because it's been asserted that there is such a again, my hand landed on the trackpad. Finally, debug. Okay, so, and again, we're supposed to sum up the priorities of the things we found, but we're only finding them every third line. So when common, and because we're collecting the information about triads, we then when we're doing this, we have to also do a second clause. So that ought to do it. So they told us the answer. Which was supposed to be 70. We execute it. And we got an error. And that's because I didn't completely clean up my old code. So I just searched for L priority. It's just priority in both places. And so we can get to see. And indeed we get 70. And indeed we get our answer. So thank you for paying attention. I hope this was interesting. I may do another one of these. This was a pretty nice one to sort of summarize.